This is R.D. Sharma's solution, class 12th. We are taking the probability chapter and third exercise. Now the initial questions are to make you aware of the formula and to use them. This is probability. P represents the probability. And this is A by B. Now first of all, you need to understand this one more time, that this is not a division. It just means you are aware, or it is being known that B, the event B has happened. Now what is the probability of A happening? That is, if B is known, what is A going to be? The probability of A. For example, if it has already rained, what is the probability of you taking the umbrella? So it is aware that the weather condition is known. So that is how the conditional probability works. A by B, A division by B is not there. It is just representation. So the formula of this A probability is PA intersection B. Now what is the common between A and B? Because B has already happened, what is the probability of A happening? Because there has to be some relationship. That is why the intersection is there. That is what is the commonality between event A and B. And what is coming to the denominator, which is PB, the probability of what has already happened. So this is the formula, the dissection I have done, and all these values which are being provided here. And if you see, this PA is already given, which is not useful here. It is already given, but people get confused. So don't worry about PA. This PA intersection B is already given, which is 4 by 13, and PB is 9 by 13. So let's write it here. We get 4 by 9. Which is the probability of this question. Now this is how you are going to write, given now all these mathematical symbols. This is very important. My intention is to give you the logic understanding, and I leave it to you. How do you write? A and B are events. A is given, B is given, A intersection B is given. You have to find out PA by B and PB by A. Let's write the formula side by side, and you will see that there are certain similarities in this formula. So PA by B or PB by A. In both of them, the numerator will remain PA intersection B, like this, PA intersection B. So the numerator will always be the intersection of A and B. What is going to come in the denominator? PB. Here PA. Whichever probability has already happened or event has already happened, the probability of that is going to come in the denominator. So A intersection B is already given, 0.2 you can write in both the equations. PB will come here, so 0.3 comes here. PA is going to come in the denominator in the second case, so 0.6 will come. So this is going to be 2 by 3 and this is going to be 1 by 3. So probability of A when B has happened is 2 by 3 and probability of B when A has happened is 1 by 3. So this is the reference for you. You can take a view out of it. A intersection B is given for two events 0.32, PB is given 0.5 and PA by B has to be found out. So A's probability when B event is known or it has already happened will be what? A and B intersection. It can be A intersection B, it can be B intersection A. Actually both are same and PB will come in the denominator. So the intersection is given 0.32, PB is already given 0.5. You can write it as 32 by 50 and the final will come as 0.64. Now if you are confused, whether my question answer is correct or not. So just remember that the probability will always lie between 0 and 1, 0 and 1 inclusive. 0.64 is between them. So just go ahead. It's correct. Now this is how we are going to do it. And you are quite aware of this formula now. So these are just starters. We have PA, PB, PB by A is given, PA by B and PA union B has to be found out. So what all is given has to be written first. This is very important so that you are aware that these all are given and this can be used for the computation of non-known activities or non-known values. So PB by A is PA intersection B and whichever is already happened, this A is going to come in the denominator. Now PA will come in the denominator. A intersection B, it is given or not? Oh, it's not given. So let's write PA intersection B like this. PA is given. Yes, of course, 0.4 is given. PB by A is given. Yes, it's 0.6. So write it here, 0.6. So PA intersection B, this equals 0.6 into 0.4, which is 0.24. 6 4s are 24. Now coming to PA by B, because A intersection B is known now. So this will be quite easy because we are aware of the formula. PA by B is going to be PA intersection B divided by what has already happened here, PB. So it will go in the denominator. 0.24 we have just computed. PB was already given 0.8. 8 3 the 24. 0.3 is going to be the result. Now PA union B, for that we have a separate result or formula. In previous exercises also we have talked about it. So PA union B is going to be equal to PA plus PB and then the intersection of A and B. That is, if you have two events A and B. Now why are you subtracting A intersection B? Because when you are unioning it, you are adding A and B. That is, in A the intersection part is there, in B also the intersection part is there. So you are adding intersection part twice. So you have to subtract it. So what is PA is 0.4. What is PB is 0.8. And PA intersection B, we have computed it 0.24 and this is going to be 0.96. PA union B is 0.96. Now this is how it's going to be done, and all those things which are given has to be written like this, and then we use the formula, and this one we have introduced in this exercise for the first time. PA by B, PB by A, PA intersection B will be used, and PA union B will be computed using again the PA intersection B. Now you have A and B two events, PA is given, PB is given, A union B is given, which is 5 by 12. A by B and B by A has to be computed. So we have used a formula just now, which is PA union B, which is equal to PA. Whenever I'm calling PA, it's actually probability of A. PB is probability of B. So just understand that these are the way of saying the probability. So PA intersection B has to be subtracted. PA union B is given. So write it here, 5 by 12. PA is 1 by 3 and PB is 1 by 4. PA intersection B can be computed here, 1 by 3 plus 1 by 4 minus 5 by 12. And PA intersection B is going to be used in both of them, PA by B and PB by A. What is PA intersection B? 1 by 3 plus 1 by 4 minus 5 by 12. That means this is going to be 1 by 6. See, 4 plus 3 by 4 is 12. So it will be 7 by 12 like this. So 7 minus 2 by 12 will be 1 by 6. So PA by B and PB by A I'm writing side by side. Just to let you know that the P intersection B is going to come in the numerator of both the computations. And in the denominator PB will come on the left and on the right PA will come. P intersection B we have already computed just now. 1 by 6 can be placed in place of PA intersection B. PB is 1 by 4. PA is 1 by 3. So let's write 1 by 3 here. So this is 4 by 6 and this is 3 by 6. So 2 by 3, which is PA by B. When B has already happened or the probability of B is already known or the event has happened, the probability of A and vice versa in this case, which is going to be 1 by 2 because 3 by 6 is 1 by 2. Now how it is going to be done, which is in front of you. All the values have to be written first, use the formula and then the normal formula for PA by B, PB by A. All the mathematical symbols are there. When you ride a bike, you need to follow certain rules on the road. Otherwise, accident may happen. So these are the rules of the mathematics. All these things you have to use. A and B are two events such that PA is given, PB is given, PA union B is given, PA intersection B, and PA by B, PB by A. Now we have just completed a question like this. So I would like you to refer to that question when the value has changed. Other things remains the same. And if you have any problem, just take this reference or let me know. We can do it again. A and B are two events such that PA is given, PB is given, PA intersection B is also given. Now we have to find out PA naught by B. Now PA naught means what is not probability of not A happening when B is already known. Okay, don't get confused. I'll just show you that these are just the way of asking questions. So probability of A naught by B is simply PA naught intersection B divided by PB. So this is the formula we are going to employ, and please keep an eye on this formula because I'm going to directly use it. So we need that this intersection A naught intersection B or A complement intersection B. Now A naught intersection B, you know the formula of this. What is that formula? In the theory of sets and via the Venn diagram, you understand that you subtract the PA intersection B from PB. That is, if I want to show you using the Venn diagram, this is your A and this is B, AB. Now you want the intersection of B along with what is not A. What is not A? Not A is of course B only. But you have to remove the intersection part, then only it will come, because there will be a part of A in A intersection B. So in all PB, if you just subtract the area of A and B intersection, because you want to remove all the parts of A that is lying in B as well. That is why PB minus PA intersection B is the formula which we are going to use in the upcoming questions also, so you need to understand it very well. PB is given 9 by 13, PA intersection B is 4 by 13. 9 minus 4 by 13 is 5 by 13. So PA complement you can write, PA naught you can write, intersection B is going to be 5 by 30. Now I have already used or intimated you the formula which I'm going to use just now. PA complement or PA naught divided by B, or sorry, it's by B, is 5 by 13 because PA naught intersection B is 5 by 13. PB is 9 by 13. This is going to be 5 by 9. So this is how it is going to be done. So I told you and I showed you how actually this is going to come through the diagram, but the formula or the way of doing the conditional probability remains the same. Next one is PA is given, B is given, PA intersection B is given. So A by B has to be computed, B by A is to be computed, PA naught by B is to be computed, and PA naught by B naught has to be computed. Now those which can be computed easily, let's start with that. Because A intersection B is already given and PA by B and PB by A can be easily computed with this. First of all, PA naught by B, this is simply the both event has to be intersected. A naught intersection B and divided by what is already known, which is PB, goes into the denominator. How about PA naught by B naught? This is first you intersect these two, PA naught intersection B naught. This is the intersection, and in the division, PB naught is going to come. Now you see here, there are certain values which are not known to us. First is PB naught is not known, PA naught intersection B is not known, and PA naught intersection B naught is not known. All other things are actually given to us. So PA by B and PB by A, that I already told you that this can be computed easily. PA intersection B will come in the numerator of both of them. PB is going to come for the first case in the denominator. PA intersection B is again in the numerator, but the denominator will have the event which has already happened, which is PA. Now let's put the values. This is going to come easily. 1 by 4 is there. PB is also known, 1 by 3. Here on the right, it's PA intersection B, which is 1 by 4 again. And PA is also given 1 by 2. So this will come as 3 by 4. And this is going to come as 2 by 4, which is 1 by 2. Now two probabilities the question is asking is already being computed. Now coming down to this one. First thing, what is PB naught? PB naught is simply 1 minus PB. Anything which is the complement has the value which is subtracted from 1, which is the probability scenario. 1 minus PB is PB naught. So 1 minus 1 by 3 is 2 by 3. PB naught is computed now. Now what do we need for all the other two? We need PA naught intersection B. The numerator of PA naught divided by B needs it. That's why we are computing it. So PB, if you subtract PA intersection B, which I already told you in the previous question. So just subtract these two. PB we have computed, which is 2 by 3 just now. PB, no, it is given 1 by 3. PA intersection B has already been given in this question, which is 1 by 4. So 1 by 3 minus 1 by 4 is 4 minus 3 by 4, 3 is 12. It is going to be 1 by 12. So 1 by 12 has come. Now we are ready for PA naught divided by B computation. Okay, let's do it first. PA naught by B. The formula I am writing again, which is PA naught intersection B, A complement intersection B divided by PB. Now we have just computed PA naught intersection B, which is 1 by 12. PB is what? It is already given in the question, which is 1 by 3. So this will be 3 by 12, which comes out to be 1 by 4. Alright. Now coming to the last one. All others are computed. PA naught by B naught. So PA naught by B naught is simply PA naught intersection B naught divided by PB naught. Now PB naught we computed 1 minus PB we have already done, and that was 2 by 3. 1 minus 1 by 3 was 2 by 3. You already know that. You have just done it. Now coming to PA naught intersection B naught. See, I am writing the complement also and the bar also above the letter. That is, both the things are not or complement. So PA naught intersection B naught is PA union B whole naught. That is whole bar. This is, we are using the De Morgan's law, which we have learned in earlier grades in this set. So 1 minus PA union B, anything complement can be computed by subtracting it by 1. That's what we have done with PB. PB naught was 1 minus PB. And PB is equal to 1 minus PB naught. That is how it goes. So PA union B is what? PA plus PB minus PA intersection B, and these all are given actually. So 1 by 2 is PA, 1 by 3 is PB, and PA intersection B is 1 by 4. So PA union B is, by all values which are given, it will be 7 by 12, because on the left if you see we need PA union B, that's why we computed PA union B. So 1 minus PA union B, which we have just computed as 7 by 12, so this is 5 by 12. Now using all these which we have computed in the equation, 5 by 12, 2 by 3 was already written by me if you remember. So this comes out to be 5 by 12 into 3 by 2, 3 4 to 12, 5 by 8 is going to come for PA naught divided or by B naught. So I have explained you all these separately, and let me also show you the formal way of doing it. So this is how you're going to go about. It was a good question. It may come in 4 to 5 marks. Now A and B are two events such that twice of PA is equal to PB is equal to 5 by 13. A double equality is there. PA by B is also given, which is 2 by 5. We have to find PA union B. So whenever the probability is coming, PA union B is PA plus PB minus PA intersection B. That we can employ here. This PA by B, this is what we need to find out. And for that we need the intersection in the numerator, that is PA intersection B in the numerator, and denominator will be PB. Now PB is already given, 5 by 13. That can be written in the denominator until we find out PA intersection B. So this PA intersection B needs to be computed, because PA union B also needs to be computed. But this PA by B is already given, which is 2 by 5, so multiply across. So PA intersection B comes to be 2 by 5 into 5 by 13. So this is 2 by 13. So PA intersection B we have achieved. Now the formula which I was telling in the beginning, PA union B is equal to PA plus PB and minus the intersection one, A intersection B. Now let's put all these values. PA is can be computed now, but PB is given directly. So PB is 5 by 13. PA intersection B is also known, so let's write it here, 2 by 13. Now from here, as I was suggesting that this is the double equality, so twice of PA is equal to 5 by 13. That is, the twice of probability A is already given as 5 by 13. So the probability of A be computed, just bring 2 in the denominator, it will be 13 into 2, which is 5 by 26. Now we can write it here, 5 by 26. So this can be computed. It's a simple computation. It will come as 11 by 26. Now this is how it needs to be done. You're already aware of all these. And next one. So PA is given, PB is given, and PA union B is given. PA intersection B has to be computed, PA by B is, and P by B, B by A is has to be computed. So what is the formula we are going to employ here? The first one is A intersection B, PA intersection B. This will become PA plus PB minus PA union B. This will be PA union B, not intersection. I'll just change it. PA is already given to us, 6 by 11. PB is also known, which is 5 by 11. Then we have PA intersection B. That I need to change it to PA union B, which is actually 7 by 11 given in the question. So 6 plus 5 is 11, 11 minus 7 is 4, 4 by 11 has come. So PA intersection B is equal to 4 by 11, which is the first one which we were expecting. Now second one is PA by B, and second and third will do it together, side by side. So second and third, PA by B and PB by A can be computed. So this is PB by A. So this equals PA by B is PA intersection B, and PB by A, PA intersection B again will come in the numerator, both of them. But whichever is already done, that is PB comes denominator. Here PA comes in the denominator. Again, PB is a slight mistake. I'll just correct it. PA intersection B we have already computed 4 by 11. PB is already given, which is 5 by 11. So this comes out to be 4 by 5. So in this case, PA intersection B is 4 by 11. PB is, no, it is PA as I suggested. So this is 6 by 11. 4 by 6 is 2 by 3. Now this is how you need to write all of these. It's a very straightforward question because simple formulas are being employed here. Now we have 3 questions alike. Similar. So a coin is tossed 3 times. Find PA by B in each of the following. A heads on third toss, B heads on first 2 tosses. Now we need to make the events, and events will be exactly similar to what is given in the question. So A can be heads on third toss, that we can make heads on third toss. This head on third toss became the first one, A event, the second event, which is B, is heads on first 2 tosses. So heads on first 2 tosses. Now whenever we toss a coin, either head or tail will come. Now this coin is tossed 3 times. So 2 possibilities are there. 2 to the power 3, 2 raised to the power 3 will be 8. So there are 8 total possibilities. So we'll just take this heads on the third toss, as there are 8 possibilities, but we are only interested in heads on third toss. So the third toss is now fixed. H, 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 H. Now the first 2 can be the combination of head and tail. So it can be head, tail, tail, head, 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 and tail, tail. So these are 4 options here. Let's write it here. See, the last one is already fixed. Other 2, the first one and second one, can be arbitrary. It can come either head or tail, both head, both tail. So these are 4 possibilities we have. So HTH or HHH, start with HHH. Then we have HTH, head, tail, head. Then we have a tail, head, head, and finally tail, tail, and head. Now in the similar fashion, the event B, heads on first 2 tosses. So when you fix head on first 2 tosses, only possibility is either head will come or tail will come in the third toss. So this B event will have these content HHH and HHT, that is head, 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 and head, head, tail, because the first 2 tosses has been fixed as heads. Now what is the intersection between A and B? You just have to find the common element of these 2 sets. So HHH we got, so just write HHH. Do we have HHT? We cannot have HHT in A, because in the first event H should or head should come in the last, but here tail is there, so only one value of one content or one element of the sets are intersected, they are only common. So the probability of A by B, that is probability of getting heads on third toss, when it is known that the heads on first 2 tosses has already come. So this will be equal to, probability is nothing but the number of elements in that set. So NA intersection B divided by NB. So we don't have to worry about the number of elements in A. And A intersection B is what? It's only 1. Only 1 we got, but NB is 2, 1 and 2. So this is how this will be done, and these are all the combination questions. Basically, if you can make this one, the probability finding is quite easy. A coin is tossed 3 times. Find P A by B in each of the following. Now A is given, B is given. A is at least 2 heads, and B, which is at most 2 heads, has already happened. So I'm writing the sets here. A is at least 2 heads. So at least 2 heads we have written. I'm just writing the same thing, no changes. But we will make the set here only. The B is at most 2 heads. That means not more than 2 heads can appear. So at most 2 heads. So at least 2 heads means you need to have 2 heads. It can come in any order. The coin is tossed 3 times. So the first and second come as head. The first and last can come as head. The second and third can come as head, and all of them can be head, because it is saying at least 2 heads should come. It is not saying that all the heads cannot come. So HHH is all the heads have come. Now coming to at most 2 heads. What does it mean? So there cannot be more than 2 heads. There can be no head. That is also a possibility. But maximum head possibility is only 2 heads, because head cannot come. The only thing here is head cannot come. So let me reiterate again the concept. For tossing a coin, the result can be only head or tail. So 2 possibilities are there, and it is tossed 3 times. So 2 to the power 3, 2 raised 3 is 8. So the total possibilities is 8. Now HHH you have to just subtract from at all the sample space. So all the sample space HHH cannot come, because at most 2 heads can come. All the 3 heads cannot come. So we have tail, tail, tail. So all these 7 except HHH, I am writing all of it. So tail, 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 head, tail, head, tail, head, 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 tail, tail, head, tail, head, head, tail, head, tail, tail. 1, 2, 3, 4, 5, 6, 7. 7 has come, because we have eliminated the HHH, because at most 2 heads can come. 3 heads cannot come. Now we'll use the same concept here. PA intersection B first of all. And probability is nothing but the number of elements in that probability set. What is A intersection B? The elements of the 2 sets which are common. or the element which is found in say A set also and simultaneously in the B set also. So HHH will not be in the B, and so all of these are there. Only HHH is not there. So 1, 2, 3, HHT, HTH and THH will come. So HHT I am rounding, HTH I am rounding and THH I am rounding. So there are 3 elements which we found simultaneously occurring in both these two sets. So let me write it: HTH, head, tail, head, tail, head, head and head, head, tail. So in all there are 3 elements. Actually we just need the number. So 1, 2, 3. Number of elements in the A intersection B is probability of A intersection B. Not probability, I'll just compute it, but it is the number which we employ in computing the probability. So PA by B is PA intersection B divided by PB. That is NA intersection B divided by NB you have to find out. And in A intersection B, I just told you that it is 3. NB is the number of elements in B. I told you the HHH cannot come. All others, that means 8 minus 1, 7 elements can come. So 3 by 7 is the required probability. So this is how you're going to solve it. And I told you the concept also. Let's write the concept also on the right. That will be better. A coin is tossed 3 times. Find probability PA by B in each of the following. Now this is similar to this one. So A and B I am not writing it. You have to write it. Please remember. A and B I am just not writing because it is already given in the question. At most 2 tails and at least 1 tail. So what A will have? At most 2 tails. That is 3 tails cannot come. At most 2 tails means maximum 2 tails can come. 3 tails cannot come, so TTT will not be there. And B set says that at least 1 tail means HHH cannot come. At least 1 tail means all the heads cannot come. That is the whole idea about this question. So at most 2 tails, TTT cannot come. At least 1 tail, HHH cannot come. So we have 7 elements. So in all there will be 8 combinations or 8 element in the set. Just remove TTT and write all the 7 combinations except TTT. So I'm writing all of them. TTH. Whenever I'm saying T, it's tail. Whenever I'm saying H, it is head. So TTH, THH, HHT, THT, HHT, HTT, HHH. Let's use the comma here. Now what is B? At least 1 tail. That is all the heads will not come. It is 1 tail. So you just remove HHH and write all the other 7 which are possible. So TTT, all the tails, TTH, THH, HHT, THT, HHT, HTT. Now let me make the round brackets followed by the commas in between and the comma between this TTH also. Means all of them needs to be understood that in an event there are different elements which are actually the experiments. Now what is A intersection B? Now you just need to find out the values which are common in these 2 sets. So we have TTH, yes we got it. THH, yes we got it. THH. HHT is also there. So you can write this HHT here. THT is there, so write THT. HHT is there, you can write this HHT also. Now in the first one HHH is there which is not found in B, and in B TTT is found which is not there present in A. So we have reached up till HHT. Now HTT is also there. So in all, how many elements are there in this A intersection B? 1, 2, 3, 4, 5, 6. So I'm just writing this. Comma is very important. Braces is important just to represent it as a set. Now this NA intersection B is needed for the probability. 6 numbers are there. 6 elements are there in A intersection B. So probability of A by B is probability of A intersection B divided by probability of B. And this is nothing but number of elements in A intersection B divided by number of elements in B. What is an A intersection B? It's 6. What is number of elements in B? There are 7. Except HHH, all of the elements of sample space will be present here. Say 8 minus 1 is 7. 6 by 7 is the probability of this question. Let me tell you again, in a coin head and tail can come. So there are 2 possibilities. Since this coin is tossed 3 times, 2 raised 3 is 8. So there will be 8 possibilities that will arise. Now let's see a formal way of solving it. If you are doing it by yourself, this is the reference you should consider. 2 coins are tossed once. Find PA by B in each of the following. Now A is given tail appears on one coin, then B, one coin shows head. One coin shows head. Now we have a coin. Now this is a fair coin. That means only head and tail can come. So there are only two possibilities. In different currency, the head and tails are different. Now you have to tell the probability that a tail appears on one coin given that one coin shows head. B is already known, or B has already happened. So there are two coins here. So both of them are toys at once or one after another. The combination remains the same. Now if you have any problem with the conditional probability, just make the events. That is, what is the sample space? Both can have heads, both can turn up as tail, one head, one tail, and one tail and one head. These are all possibilities. So head or tail possibilities are there. So two possibilities, two coin, 2 to the power 2 or 2 raised 2 is 4. So 4 combinations. So the first event, tail appears on one coin. So tail can appear at first, that means, and tail can appear later also. One tail should appear. So what do we write here? Tail, head and tail. So we fixed one as tail, the first one or the second one, and then we inserted head. Now in the second event, one coin shows head. Again, we are fixing head, first time head, second time head. So the second time head or first time head. These are all the possibilities here. Now PA by B formula is quite known to us. It's PA intersection B divided by the probability of B, the event which has already happened or event whose probability is already known to us. So we actually write the number of elements here. What is the number of element of A? We don't require it. What is the number of element in B? There are two, HT and TH. Now we need to find out the intersection. PA intersection B means in the set A and B, what are common values? TH is also there and HT is also there. That means it says that TH and HT, that is 2. Number of elements in A intersection B is 2. So we'll use this formula here. Let's do it here only. Number of elements in A intersection B is 2. Number of element in B is 2. 2 by 2 is 1. So this is how it will be done. This is a formal way of doing it. Whenever you are going to write it like this. Now sample space is very important. I wrote the sample space. I would like you to insert a sample space also here so that the examiner knows. Now two coins are tossed once. Find P A by B in each of the following. So we have two coins again. And what is the sample space? Both can turn up head. Both can have tails, one head, one tail, and one tail and one head. Now I'm not writing A and B now because these are the repeated questions of two coins being tossed. A is no tail appears. So there is no tail. When there is no tail, these three possibilities cannot come. Only head and head can come because only head and head has no tail. So number of elements in A is only 1. This should be in bracket. How about B? No head appears. No head appears means this cannot come, this cannot come, this cannot come. So only tail and tail is the possibility because if tails are coming in both the coins, no head is appearing. So T comma T is again the set. So number of element in B is what now? It's 1. Now probability of A intersection B, that is what are the elements which are common in A and B together or they are found in both the sets. So PA by B is PA intersection B divided by PB. You can write N also here. Computation will be through N only. Number of elements in A intersection B. Now what is the commonality? Nothing is common. So now N of A intersection B is 0. There is nothing common. So this will be 0. Number of elements in B will be 1. So let's write it 1. It will be 0. So probability always lies between 0 and 1. 0 and 1 inclusive. Previous question it was 1. This question it is 0. Again, please write the sample space. Now A intersection B, I told you what has come, but you have to write it as a 5. 5 means nothing. Nothing is also something because nothing is, there is nothing. So it's 0. 0 is also a value. A die is thrown 3 times. So this is a die. A die is a six-phased shape which is a cube, and in this cube all the faces will have number from 1 till 6. 6 faces, 6 numbers. So a die is thrown 3 times. So the question remains the same if the 3 dice are thrown say at the same time. If this question would have come, we would have solved in the similar way. So a die can give 6 possibilities, 1, 2, 3, 4, 5, 6. So 6 possibilities can come and it is being thrown 3 times, 6 to the power 3. This is the sample space. So I would not like you, or I will not like to encourage you to write all the sample space. It is not required here. PA by B and PB by A has to be found out. A and B is already given. B has already happened. B is 6 and 5 appear respectively on first 2 tosses, and this A is 4 appears on the third toss. So they have fixed certain values that will reduce the experiment values. Alright. So the A set is 4 appears in the third toss. You have to write in totality what is given in the question. You need to write 4 appears on the third toss. When 4 comes in the last, this last position is fixed now. Now first and second die, first or second toss can give you 1 1 1 2 till 1 6. Then you have 2 1 2 2 2 3 2 4 2 5 2 6. Then 3 1 3 2 3 3 3 4 3 5 3 6. Then 4 1 2 4 6. Then 5 1 2 5 6. Then 6 1 2 6 6. 4 in the end will remain the same. Let me write it here. Let me make a set. 1 1 4 1 2 4. So I hope you understand. 1 1 4 1 2 4 1 3 4 1 5 4 1 6 4. Then 2 1 4 2 2 4 2 3 4 2 4 4 and 2 5 4 and 2 6 4. So every row has 6 elements. Again 3 1 3 2 3 3 3 4 3 5 3 6. Why I'm not speaking about 4? Because 4 has to come in the last one always. A die is thrown 3 times. The third time 4 should appear. So first and second options are free to us. So whatever possibilities are there, which we are making right now. So I'm writing all of these in short just to make you understand. The last one will be 6 1 6 2 6 3 6 4 6 5 6 6 and followed by 4 each and every time. So now I'm writing 4 just to signify, just to let you know that in all the combinations 4 is going to come in the last. And now every row is containing 6 elements. I hope you got the idea. 1 1 4 1 2 4 1 3 4 1 4 4 1 5 4 1 1 6 4. These are 6 elements in the first row. So in the similar way, we have 6 rows and 6 columns. So 6 into 6 is 36. Or you can say the first row will have 6 values, second will have 6 values, third 6 value, 4 6 5 6. All the rows will have 6 values. So 6 into 6 is 36. So number of elements in set A has come as 36. Now coming to set B. Now set B is easier for us. 6 and 5 appears respectively on first 2 tosses. So 6 5 you fix. So the third one can be 1. Now let me fix this 6 5 first. 2 can come, then 6 5 has to come in the first and second toss. So 6 5 1 6 5 2 6 5 3 6 5 4 6 5 5 and 6 5 6. These are only possibilities when 6 and 5 should come in the first 2 tosses, and the third can have 1 to 6 values. So number of element in B is 6. Now probability of A by B, that is the probability of A when B has happened, and probability of B when A has happened. So both the probabilities we are doing together. For this we need PA intersection B, and here also we need PA intersection B in the numerator. Denominator in the first case will be PB, denominator in the second case will be PA, and just change it with N also. In the next line just write N because we are dealing with the numbers. We need numbers to find out the probability. So what is PB or NB is 6. What is NA 36? We have already found out. We have a long discussion on this just now. Now what are the values which are common between A and B? See, in the first set only 4 can come in the last. So in the second set you just have to find out that value which has 4 in the last. So only 6 5 4 and 6 5 4 will match. So in the last row of A, just assume that we have 6 1 4 6 2 4 6 3 4 6 4 4 and 6 5 4 and 6 6 4. So the last but one 6 5 4 will only match with the fourth element of B, which is 6 5 4. That is A intersection B will give you 6 5 and 4, which is the only common element between set A and set B. So NA intersection B has come as 1. Just write 1 here. 1 by 6 is the probability. First one and second one is 1 by 36. Now this is the way you are going to go about it, and I hope you got the logic behind this. This was a very good question. Only the sample space you don't have to write. Otherwise things are quite easier to you. So the first A set has 36 elements, B has 6 elements, common is only 1. Mother, father, son line up at random for a family picture. So let's make a representation of them. Just to let you know that first one, second one and third one. So these three all positions are random. Alright. Anyone can stand anywhere. If A and B are two events given by A, son on one end, B is father in the middle. Find P A by B and P B by. So this is mother, this is father, this is son. So A is a set that is saying son is standing on one end. It can be left end, it can be right end. Both the ends are there. Let me make the sample space first. See, the whole possibilities is mother, father, son, or mother, son, father, or father, son, mother, or father, mother, son, mother, father, son, father, mother. So these are the all possibilities. So it will be 3C2 combination actually. If you are aware of the permutation and combination, it will be 3C2. So let me write it in a formal way. MFS, MSF, FSM, FMS, F for father, M for mother, S for son. So I am writing all these 6 because you have to write in this way. You have to make a set like this. So all the 6 has been taken care of. Now what is A saying? Son standing on one end. So son has to be either on left or either on right. So son is here on the right, son is here on the left, and son is on the left on the third also, and first one also. So the A set will be what? You just have to see if sun is not in the middle. If sun is in the middle, you will not take it. Others you have to take it. So MFS, father is in the middle, FMS, mother in the middle, SMF, mother in the middle, and SFM, father in the middle. Or in other way you can say sun has to be on either left or right. Now what are the number of elements in A? Just count them. 1, 2, 3, 4. 4 of them. Now coming to the set B, father in the middle. So when we are talking about father in the middle, that means you have to just see the father has to be on either side, or just take F which is in middle. So MFS and SFM, these are only 2 possibilities where the father comes in the middle. The same question if mother in the middle, then also it remains the same. Father on one end, mother in the middle, same solution will happen. So this B number of element has become 2. A intersection B, MFS is common. I am now finding the common values in A and B. MFS is there and SFM is there. So you have SFM here. So NA intersection B, these are 2. PA by B and PB by A. So let's do it together so that because the numerator remains the same in both the cases, it will be NA intersection B. Actually you have to write PA intersection B. Ultimately we have to deal with the number of elements only. That's why we're writing NA intersection B. Here also NA intersection B. In the first case, NB in the denominator, second case, NA in the denominator. We have already computed the number of elements. NA intersection B is 2 in both the cases. NB has come to be 2 and A was computed as 4. So right here 4. This is 2 by 2 is 1 and 2 by 4 becomes half. So PA by B has become 1, PB by A has become 1 by 2. So this is the way we are going to do it. Okay, sample space is very important here. Diagrammatically, its representation will be appreciable. A dice is thrown twice and sum of the numbers appearing is observed to be 6. What is the conditional probability that the number 4 has appeared at least once? Now again, I am reiterating. A dice 6-faced cube, 1 to 6 numbers are being printed or engraved. So there are 2 dice here. 1 die 2 times or 2 dice at the same time, the computation remains the same. Now when 6 will come? 6 will come when we have 1 and 5 or 5 or 1, 2 or 4, 2 or 4 or 4 or 2, 3 and 3 and 3 and 3 in the first and second or vice versa. Now what is required here? Let's write the sets here first because we have to start with the experiment. Experiment have different events and events are the set elements. So B is here, sum on the 2 dice is 6 because this is already given. A, I'm writing it in short. A is a number 4 has appeared at least once. 4 appears at least once. So the A set will be what? Now let's make B first. You will know why I'm making this. Sum is 6. What is sum 6? I just told you. Please remember a set cannot have repeated value. Redundancy is not allowed. So I told you here, the 6 can come only when we have 1 and 5, 5 and 1, 2 and 4, 4 and 2, and 3 and 3. So 1 and 5, 5 and 1 I am writing first, 2 and 4, then 4 and 2, 4 comma 2, or we have 3 and 3, 3 and 3. 3 can come in the first, 3 can come in the second, and vice versa. But the set only allows us to write 3 comma 3. Now coming to A, 4 appears on a die. Now 4, if it appears, the other option can be 1 to 6. So 4 1 can come, 4 2 can come, 4 3 can come, 4 4 can come, 4 5 can come, and 4 6 can come. And if you swap the dice, 1 4 can come, 2 4, 3 4, 4 4, 5 4, and 6 4 can come. So these are the set values of A. But we are interested in the number of elements in A and number of elements in B, because in order to compute the probability we need the numbers. What is the number of element in A? We don't require it. Do we require it? Because the probability of A by B is probability of A intersection B divided by probability of B. So you don't need to compute N A. N B is required. These are 5 elements in here. A intersection B will be what? What is the commonality? Just see. 1 5 is there. See, only if 4 comes first or 4 comes at the last, then only the possibility is there. So 2 4 and 4 2. So 2 4 is there, 4 2 is there. These two are common. So there are only 2 values, or 2 4 4 2. The number of elements in A intersection B comes out to be 2. You have to count the elements in this set, which would be 2. So now put it in this formula, and intersection B is 2. PB has come to be 5. 2 by 5 is the answer, is the required probability. So this is how we are going to write it. Okay, now this is quite clear now, I hope. 2 dice are thrown. Find the probability that the numbers appeared has the sum 8 if it is known that the second die always exhibits 4. Now die you already know. So we are talking about 2 dice here. A die has 6 faces marked from 1 to 6. So first one can give you 1 to 6, second one also can give you 1 to 6. So there are 2 dice, there are 6 possibilities. So 6 raised to 36 is the sample space. That is all the combination which are possible of number 1 to 6 for both the dice are 36. Find the probability. Now probability is A by B. Now this time we'll do a reverse. That is to make you understand that both the things are okay if it is being presented or shown to you, or if you write like this. The probability which is below has already happened and above is to be found out. So A, we will mark an event that 4 appears on second dice. So number appeared has the sum 8. Now this is what we need to find out. A has already happened. Second die always exhibits 4, always turns out to be 4 is A. Now B is the number has appeared 8. So number appeared has sum 8. Now let's make the events and elements. Now 4 is fixed in the first case. 4 appear in the second die. First can come from 1 to 6. But the second is fixed. So the first can come as 1, 2. So I am fixing the last one, the second die. The first can be 1, 2, then 3 can come, 4 can come, 5 can come, 6 can come. So this is the event A, or all the experiments which you see for event A. Now what is the number of elements in A? A 1, 2, 3, 4, 5, 6. So it is 6. Coming to B. Now probability of B by A, the numerator remains the same for B by A or A by B. This is number of elements in A intersection B divided by number of elements in A. So the number of elements in B will not be required, but A and B intersection is required. That's why we have to write the event B and the set values. So B is number appeared has sum 8. So 4 4 give you 8, 3 5 give you 8, then 5 3, then 2 6, and 6 2. So 4 4 can come in both of them, but this set has the property that the redundancy cannot be there. So only 1 4 4 will come. Now what is A intersection B? A intersection B means we have to find out those elements which are common in A and B, which are found both in A and B. So 4 is fixed in first case for the second die. So only this 4 4 can be taken, or this value is the only common value between A and B. So only one element is there. Now the formula is what? NA intersection B divided by NA. NA intersection B is 1. And what is NA? Number of elements in A? It's 6. So 1 by 6. So probability of event B when A has happened is 1 by 6. Now this is how this will be done. A pair of dice is thrown. Find the probability of getting 7 as the sum if it is known that the second die always exhibits an odd number. So we'll do P by B by A here. That will be, we'll make A and B just now, but let me reiterate the formula or the equation. PA intersection B divided by PA. So we need number of element in A intersection B, number of element in A. So what is A here? A has already happened. So if it is known means it has already happened. The second die always exhibits an odd number. So I'm writing it in short. A we can write it as number appeared on second die is odd number. So what are the odd numbers? See, there are 6 possibilities and in all there are 2 dice. So 36 is the sample space. And in this sample space, those numbers which are odd 135. So this is about the second die. So 135 can come as the second number. But the first can be 1, 1, 1, 1, 1, 1, 3, 1, 5 is a combination. Then 2, 2, 2, 2, 1, 2, 3, 2, 5. 3, 1, 3, 3, 3, 5, 4, 1, 4, 3, 4, 5, 5, 1, 5, 3, 5, 5, and likewise we go up till 6. So I'm writing it now. So 1, 1, 1, 3, 1, 5, 2, 1, 2, 3, 2, 5, 3, 1, 3, 3, 3, 5, 4, 1, 4, 3, 4, 5, 1, 3, 5 is 6 for the second die. I'm just changing the numbers 1 till 6. So 5, 1, 5, 3, 5, 5 and 6, 1, 6, 3, 6, 5. So this is how you have to write, and all of these experiments in this event are elements which has to be inside the round brackets and they need to be separated by comma in between them. That's the essential part of doing this. Now this NA is what? Number of element in A. So there will be half even, half odd. 36 are there. Just half it, 18 will come. The number of element in A, if you count it also, it will come as 18. Now you don't need to find out NB, but this set B needs to be found out because we need A intersection B, the elements which are common in A and B. Now the probability of getting 7 as the sum is the B set. So first 2, then 5, then 5 and 2, then 3 and 4, then 4 and 3, 1 and 6, 6 and 1. So all these which you see inside the brackets, the sum will be 7. So they are making 7, and since both the die we are taking care, so anyone can have certain numbers and that can be reversed also to get a 7. Now A intersection B is what? The common values between A and B. The A has only 135 at the end. So this 2 and 4 cannot come. 1, 6 cannot come. All the odd number which are the second die in B cannot come. So 2, 5, 4, 3 and 6, 1. These are the elements you will find both in A as well as B. So number of element in A intersection B is 3. Just count them. So the formula we have written earlier, P intersection B is 3 or NA intersection B is 3 and NA, number of elements in A is 18. So 1 by 6. B by A is what? 1 by 6. That is your result. Now this is how you need to write it, and the 2 die, the proper combination and the sample spaces, if you are aware, then this question will be quite easy for you. So the common values are this and the required probability is this. A pair of dice is thrown. Find the probability of getting 7 as the sum if it is known that the second die always exhibits a prime number. Now we have 2 die and these are being thrown or tossed. Now this 7 should come as the sum. So we'll make 2 events. B is sum of numbers on 2 dice. So this is 7. When you add the values which come up in 2 dice, it should be 7. So 2, 5, 5, 2, 6, 1, 1, 6, 4, 3, 3, 4 will come. If it is known, that is this is already happened or it is known probability that the second die always exhibits a prime number. So prime number is what? 2, then 3 and 5. So let me write it officially. Prime numbers are those numbers which are divisible by either themselves or no other. So in this, 2 also, you will say 2 divides itself and 2 is an even number. No, 2 has a separate explanation for that. But you know that 2 is a prime number. 3 is a prime number. 5 is a prime number. So odd numbers are not always prime numbers. This has to be known very clearly. Like if you take 15 15 is not a prime number because it is divisible by 3 as well as 5. Numbers which cannot be divided by any other number, like 19, like 17. So set B. This is sum of numbers on 2 dice is 7. We have just done it, means a question like this. Let's make A first. Second die is exhibiting a prime number. Either it can be 2 or 3 or 5. So 2, 3, 5. Write it 6 times. Why I'm saying it? Write 6 times. Because first time 1, 1, 1 can come. 2, 2, 2. Then all this 2, 3, 5 you can write it 6 times. Because this is going to come in this second die. The first die can have 1, can have 2, can have 3, 4, 5 and then 6. So this is why I have written like this in a matrix form, because the counting becomes easy. If you write it in just one line, the counting may be a problem. So just see that there are 3 columns and 6 rows. So 6 3s are 18. Number of elements in A is 18 now. Now sum of numbers on 2 dice is 7. 7 means 1 6 6 1 and 5 2 2 5 4 3 3 4. So this all combination means first and second die number being added should come up as 7. So 2 5 5 2 3 4 4 3 and 1 6 6 1. So these all has come here. You don't need to find out NB because it is not required as per the question. PB by A formula says that it has to be NA intersection B divided by NB. NA, sorry, not NA, it will be. NA intersection B already found out 18. The number of elements which are common in both of them. So we are now trying to find out A intersection B. And please remember only 2, 3, 5 can come in the end. So 2, 5 is a common number. 5, 2 is a common number. That means these two. 4, 3 can come. 4, 3. The others will not come. You will see that only these are common. So number of element in A intersection B has come as 2, 5, 5, 2 and 4, 3. So these are 3 numbers. So 3 by 18, 1 by 6 is the correct answer. So this is how you can write it whenever you are writing it. And you can take a reference from here also. A die is rolled. So we are talking about just one die. If the outcome is an odd number, what is the probability that it is a prime number? Let's make the event. So we have A and B. A is that number is odd. B is number is prime. Now we are writing the formula now, PB by A. Now when it is known that if A has already happened, what is the probability of getting B? That is why if it is known that the number is odd, what is the probability that the number is prime? So PA intersection B or PB intersection A divided by number of elements in A or probability of A. Let's make the set now. A's number is odd. So in a die 1, 2, 3, 4, 5, 6. All these 6 numbers can appear on the face up. What are the odd numbers? 1, 3 and 5. These are the odd numbers. The number of elements in A is 1, 3, 5. So 3. In the B set, it is number has to be a prime number. So 2, 3, 5 are the prime numbers. You don't need to find out the number of elements in B. A intersection B has to be computed. What are the elements which are common in A and B? 3, 5, 3, 5. So 3 and 5 are the common numbers between A and B. Number of elements in A intersection B is 3 and 5. So these are 2 numbers. So let's write it in the formula. Number of element in A intersection B is 2, probability of A and A is 3. 2 by 3 is the correct answer. So the 2 by 3 is a high probability. Now this is how it has to be written. A pair of dice is thrown. Find the probability of getting the sum 8 or more if 4 appears on the first die. Now you are aware that the die is a 6th phased shape. 1 to 6 can come. So let's make A and B, which are the events. When it is given if or if it is known that it is a conditional probability question. So we'll make the events A and B like this. Find the probability of getting the sum 8 or more. This will be B. It depends on whether you take PA by B or PB by A. Because something has happened, then you have to tell the probability of something. That is how the conditional probability works. So sum of 2 dice is 8 or more is B. A will make as 4 appears on the first die. So 4 appears on first die. Now you have to fix that 4 appears on first die. There is no other number which can appear on the first die when it is thrown. So this is 4. The next die 1 to 6 can come. So 4 you can fix like this. 4, 4, 4, and then 1 can come, 2 can come after that, 3, 4, 5 and 6. So you see here, these are all the possibilities. Separate by a comma, that the representation has to be quite good, because this is how we represent this set. So number of elements in A is 6. You can count them. From 4, 1 to 4, 6, it's 6. B is sum of 2 die, and these dice have 8 or more. So from here to here, anything which is above 8 inclusive. For example, 5 and 6 will give you what? 11. 11 is more than 8. So we have 2, 6, and whenever you write this, you can reverse it and write it together. Because if 2, 6 is 8, 6, 2 will always be 8. 3, 5 is 8, so 5, 3 also will be 8. In a set, multiple entries are not allowed. So 4, 4, this 4, 4 can be from either of the dice, but only 4, 4 can be written. Then 5, 4, 4, 5, this is for 9. Then 6, 3 and 3, 6. 10 is 5, 5, 6, 6 is 12. 6, 4 and 4, 6 will also give you 10. So 6, 4 and 4, 6. We need to add this 5, 6 and 6, 5 for 11 also. Now let's count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have number of elements in B as 15. Now we need intersection also. A intersection B is what? The common values between this set A and set B. So only you have to see in B what all starts with 4, because A is already fixed with 4 in the first die. So 4, 4, then 4, 5, then 4, 6. So number of elements in A intersection B is 3 now. Now let me write the formula here only. P A intersection B. So P A intersection B divided by PA is what? PB by A. So I'm writing it here now. PB by A is simply the number of elements in A intersection B divided by number of elements in A. So 3 divided by 6. 1 by 2. Half is the correct answer. So this is how you are going to write it. Find the probability that the sum of the numbers showing on 2 dice is 8. Given that at least one die does not show 5. Okay, so 5 should not come. That's what they are saying. In all the sample space, wherever 5 is there, just you have to delete that, or you have to ignore that. Now A, we will taking it as at least one die does not show 5. Cross is for does not show, just for representation. Now B is sum of number showing on 2 dice is 8. That is the number appearing on both the dice. When they are added, it should be 8. So we have 2, 6 as 8. So this table is showing the intersection points where 8 is coming. So 2, 6, 6, 2 will give you 8. 3, 5, 5, 3 will give you 8. And 4, 4. Actually there should be 2, 4, 4. But the set properties and the rules says that redundancy and multiplicity is not allowed. That's why we are not writing 4. Now what is A? At least one die is not 5. So make all the sample spaces and just remove any of the entry with 5 in it. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 will come, but 1, 5 you have to just ignore. That is 1, 5 will come, but in this case A, making A, you have to ignore it. Similarly 2, 5 have to be ignored, then 3, 5 have to be ignored. So I'm just cutting it out just to let you know that this is whole sample space I am making of when 2 dice are being thrown, but all the elements with 5 like this 4, 5 I am again ignoring. Now this 5, 1 to 5, 6 all will contain 5, so we don't want this 5. So whole line you need to ignore. All 5 1s, 5 2, 5 3, 5 4, 5 5, 5 6 you have to ignore. Then again 6 5 has to be ignored. So in all the sample space of throwing 2 dice are 36. And if you count the number where, or count the element where 5 is coming, these are 11. So you need to subtract them from 36. So 36 minus 11. 11 are those entries where 5 appears. So it becomes 25. So number of elements in A is 25. Now A intersection B. So all these 5 entry cannot come which are B in B, because A does not contain 5. So 5, 3, 3, 5 cannot come. All others can come because A is actually the whole sample space except values where 5 appears. So 4, 4, 6, 2, 2, 6, all these are the values which are common in A and B together. So number of elements in A intersection B is 3 now. So PB by A is number of elements in A intersection B divided by number of elements in A. A intersection B is 3 and NA is 25. So 3 by 25. Now let's see how it will be done. This is how you have to write also in view of your examination. Two numbers are selected at random from integers 1 through 9. If the sum is even, find the probability that both the numbers are odd. Now this is a tricky question. First, let me just write this 1 through 9. So this is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now how many total numbers are there? The total numbers are 9. If you count from 1 to 9 on your fingers, it will be 9. How many even numbers are there? Because you'll see what will happen just now. Even numbers 2, 4, 6 and 8. So just write 2, 4, 6 and 8. These are even numbers. How many odds are there? Odd numbers are there. 1, 3, 5, 7 and 9. So 1, 3, 5, 7, 9. These are the odd numbers. And how many numbers are there? 5. Now coming to the question. Find the probability that both the numbers are odd. So let's make it as O. Both numbers are odd. This is our O. I am representing this as a probability O. If the sum is even, let's make it as S. Sum is even. So the probability, if the sum is given, that is, it is a conditional probability. And whatever is given goes below. So PO by S has to be computed. That is equivalent to PO intersection S divided by PS. That you already know. Now let's first compute this PS. So probability of getting sum which is even. And please remember, every time we are selecting two items, two numbers are to be selected. So whenever you select the two numbers from even numbers and add them, the result will be an even number. Similarly, if you choose two elements from the list of odd numbers and add them, that will also be even numbers. 5 plus 1 even, 7 plus 3 10 even, 9 plus 5 it becomes even 14. So you are choosing 2 from 4 and 2 from 5. So 4C2 plus 5C2. These are the favorable cases. And what are the total number of cases? You are picking 2 from all these 9s. So total number of favorable cases are picking 2 from even, picking 2 from odd, because they are going to give you even numbers. And total number of cases are 9C2 because you are selecting in random 2 from 9. So I hope you got this idea. Permutation and combination means you are choosing 2 or n r number from n numbers. And what are the combinations possible? And favorable cases divided by total number of cases is the probability. So we have written the probability accordingly. Now let's come down to probability of O intersection S. You can also find the probability of O, then find the intersection. But it is better to have O intersection S because we are going to get it from here only. See, total number of cases will remain the same. We are picking 2 from 9. So 9C2 I am in the denominator. But what about O intersection S? The sum should be even and both numbers are odd. So you have to pick only from the odd. How many numbers are odd? 5. You have to pick only 2 numbers from odd. And we know when we pick 2 numbers from odd, they will always add up to an even number. 1 plus 5 is 6. 9 plus 1 is 10. You pick any of these. So O and S, both the conditions, if we need to make them hold true, so it is only 2 taking from the odd. So now this has come. Now using the formula, divide this. So 5C2 by 9C2 divided by 4C2 plus 5C2 divided by 9C2. 9C2 gets cancelled. You have 5C2 divided by 4C2 plus 5C2. See, NCR is what? NCR is factorial n divided by factorial r divided by factorial n minus r. So factorial 5 divided by factorial 2, factorial 5 minus 3 is 5 minus 2 is 3. So this becomes 5 into 4 into factorial 3. Factorial 3 is already there. 3, this gets cancelled. Factorial 2 is 2 only. So 5 4 is 20. 20 divided by 2 is 10. 10 will come in the numerator. Similarly, NC2 will come as 16. This denominator comes as 4C2 plus 5C2. When you add, it is going to come as 16. Can you try yourself? 4C2 plus 5C2 is 16. 5C2 is 10. 10 by 16 is 5 by 8. So this is the short version of what we were intending to do. Okay, you can just try it. A die is thrown twice and sum of the numbers appearing is observed to be 8. So again, same thing we are doing. I hope you are now comfortable with the dice questions. So we have 2 dice. Twice they are being means 2 dice, 36 options which can come. What is the conditional probability that the number 5 has appeared at least once? So A we will make as 5 appears at least once. It can be on either die. Both can also come, but at least one face up should be 5. What is B? Sum of numbers on 2 dice should be 8. That is, when you add up the numbers in the die, it should come as 8. It should add up to 8. So how this 8 can come if we are making the set B? 2, 6, 6, 2, 3, 5, 5, 3 and 4, 4. That is now learned by heart to us, because we have already done this. So number of elements in B is how many? 1, 2, 3, 4, 5. 5 are the number of elements in B. Coming to A, 5 appears on the die at least once. So just take the combination of 5, that is 5 comes, let's fix 5 in the first die first or the second die first, and this is how, or make the combination with 1 and 6. So 1, 5, 2, 5, 3, 5, 4, 5, 5, 5 and 4, 4, 5 and 5, 5 and 6, 5. These are 6 values. I'll just write this 5, 5. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. I haven't written the 5, 5 in the first case, because in this set, the multiple values are not allowed. Redundancy, it is not allowed. So you just have to write 5, 5 once. Though it is going to appear twice, but you just have to write once. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 6. 5, 6 should also come. But 5, 5 I need to write only once. That is the whole idea of forming a set. Or the better way is to just fix the last or second die as 5 and just mark 1 to 5 here for the first die. And in the similar manner, fix the 5 in the first die, and then second one as these are all 5, and the second one as 1 to 5, 1 2 3 4 5. But remember, only writing 5 5 once. So these two needs to be made as 1. That is the whole idea. We don't need to compute number of elements in A. We just need A intersection B. See, in A, everywhere it is 5 somewhere. One first or second one. So just take the elements which are having 5 in B. So 3, 5 and 5, 3 will only be the option which we can get, because the A set does not have any value without 5. And taking B where 5 appears is 3, 5 and 5, 3. Number of elements in A intersection B will be 2. So number of elements in both the cases are known now. PA by B is NA intersection B divided by NB. So first you write probability, then convert it into number of elements. So this will be what? 2 divided by this 5. So this is the answer. And this is how you are going to go about it. 2 dice are thrown and it is known that the first die shows a 6. Find the probability that the sum of the numbers shown on 2 dice is 7. Now in a die, you know, that is 1 to 6. There are 2 dice. So 36 is the sample space. Let's make the event. So the A event is first die shows a 6. So first die will always show a 6. Then the next event will be the sum of the numbers in the 2 dice. When we add them, that should be equal to 7, or that will come as 7. So this A event will be like this. We are fixing this 6 as the first outcome. So 6, 1, 6, 2, 6, 3, 6, 4, 6, 5 and 6, 6 can come. So this is A set. Now coming to the set B, sum should be 7. So now this whole line which you see here, just take the row and column die number, they will give you 7. Only in a set you have to be careful that the same entry is not allowed multiple times. So 2, 5 and 5, 2 both are 7. Similarly 4, 3 and 3, 4, if you add them, they will also give you 7. Then 1, 6 and 6, 1. Again, add them, you will get a 7. So number of elements in A is what? 1, 2, 3, 4, 5, 6. It is 6. Number of element in A is 6. Number of elements in B, so it's 5. 6. 1, 2, 3, 4, 5, 6. Now let's take the A intersection B. What are the common values? Or what are the elements in both the sets which are common? So this 6, 1 and 6, 1 are common. Only this 6, 1 is the only common value between NA and this PA and PB, or the set A and B. So the NA intersection B, that is the number of element in A intersection B, is 1. So the probability of 2 dice are thrown, if it is known always comes below. So we have A in the below part, the sum of the numbers showing 2 dice is 7 is B. So PB by A will be P A intersection B or PB intersection A divided by PA. Just change it to N because we are dealing with the numbers. This will be 1 and NA actually. It's 6. So 1 by 6 it is. So this is how you are going to go about it. A pair of dice is thrown. Let E be the event that the sum is greater than or equal to 10. And F is the event pi appears on the first die. Find PE by F. Now if F changes to an event, F appears on at least one die. Find PE by F. So we have to have E, F, then EF. E remains the same, but F changes. So it's basically two questions in one question. So we'll deal it with like that only. So let's make the events first. E. Since F are similar in the question, so we'll just differentiate using as a F1 or F2. So E is the event that sum is greater than or equal to 10. So I'm writing it. You have to write it completely. So sum must be 10 or 10 plus 10, 11, 12. So the highest number can come as 12 only because most highest number is 6 only. 6 plus 6 is 12. Now making the first F, 5 appears on first die. So E will be what? Sum is 10 or higher. So what it can be? 4, 6 is 10. 6, 4 is 10. 5 by 5 is also 10. 5, 6, 6, 5. They both are 11. Then 6, 6. So if you see all these numbers, two numbers if you add, it will be either 10 or higher. So the first F event is 5 appear on the first die. Let's call it as F1 and F2 just to differentiate that these two are separate questions and we are dealing with them one by one. So this F1 and F2 I am just renaming to explain you. First F, that is F1, comes as 5 appears on the first die. So the first number 5 is fixed. The second can be 1 or 2, 3, 4, 5 and 6. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. All these can come. Now coming to F2, which is the second F, 5 appears at least on one die. So you can fix the first number as 5 and then the second number as 5. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6 can come. Then the 5 can come in the second die also. So 5, 5, 5, 5, 5. I am writing 6 here, means 6 times 5. But there will be a catch. I'll just tell you what is the catch. 1, 5, 2, 5, 3, 5, 4, 5, 5, 5 and then 6, 5 also. So in all there are 12 entries here. But if you see 5, 5 is repeated here. You need to be very careful about the brackets because the set has to be represented. The same values are not allowed. So this 5, 5 you can eliminate. One of the 5, 5 you can eliminate. Just keep 1, 5, 5. So in all there will be 11 entries here. How many entries in F1? Which is 6. How many elements in E? 6. Now probability can be computed, but before that we need to have the intersection values. So E intersection F1 and E intersection F2. So there are two separate questions as I was suggesting. So I'll do it in front of you only on the same screen. But assume that they are different because the question wants you to do it separately. Now the intersection of E and F1. So we have 5, 5 first. Then we have a 5, 6. So number of elements in E intersection F1 is 2 now. Now E intersection with the second F, which is F2. So what are the elements which are common in both these? So 5, 5 again, we got it. Then 5, 6, then 6, 5. 5 will be everywhere. Now what is the number of elements in E intersection F2, which is 3. Now taking the probability formula is simply E by F. This is P E intersection F divided by PF. So first I am taking P E by F, which is I am calling it as F1. Second one is P E by F2. I am calling it as F2. They are F only in the question, but I'm just suggesting F1 and F2. So number of elements in E intersection F1 is 2. From here I have taken the number of elements in F1. We have already computed that. So it's 6. So 2 by 6 it is. Now here number of elements in F2 is 11. And intersection gives you what? E intersection F2 is 3. So we have 1 by 3 and 3 by 11 as the answer of two parts. So this is you have to do first. The E remains the same. F changes and accordingly the results also changes, intersection also changes. So I hope you got the idea. This is how you're going to go about it. So these are two cases and separately you have to do it. The probability that the student selected at random from a class will pass in mathematics is 4 by 5. Now if you select them in random, any of these students, it will pass in mathematics. The probability is 4 by 5, and the probability that he or she passes in mathematics and computer science both, and means it's an intersection. That is, the student has to pass both in mathematics and computer science together. What is the probability that he or she will pass in computer science if it is known that he or she has passed in mathematics? Now if we assume or we know that he or she has passed in mathematics, what is the probability of he or she being passed in computer science? So let's call it M and C. M for mathematics and C for computer science. So M is what? So passing in mathematics. C is mathematics and computer science passing. This is, we are calling it as C. So C is actually mathematics and computer science both. The probability of maths is 4 by 5 given. Probability of math intersection computer science is half. So probability of mathematics is known. What is the computer science formula? So it is P C intersection M divided by PM. C intersection M is half divided by 4 by 5. Let me just check. C is only the computer science, okay? So I'm changing my statement now. So the final answer is 5 by 8. Let me show you also. M is mathematics and C is computer science. The probability that certain person will buy a shirt is 0.2. Let's make it like this. S for shirt and T for trouser. So probability of a shirt that certain person is going to buy a shirt is 0.2. Now the probability that he will buy a trouser is 0.3. So PT, I'm representing the probability of trouser. The probability that he'll buy a shirt given that he buys a trouser. The probability of C, it's a conditional probability. So what is known goes below. So this trouser is being brought, but what is the probability of buying a shirt after buying a trouser is 0.4 given in the question. What is the probability that he'll buy both shirt and trouser? So P shirt intersection T needs to be found out. This is the first part. Second part we are just going to take, but let's solve the first part. PS by T is PS intersection T divided by PT. So this whole PS intersection T will be PS by T multiplied by PT. We are just cross multiplying it. And now we have both the values. PS by T is already given in the question, which is 0.4, and PT is 0.3. So 0.4 into 0.3 is 0.12. How about the second part? Find the probability that he will buy a trouser given that he buys a shirt. So it's just the inverse of PS by T, which is PT by S. So when shirt is known to be bought, what is the probability of buying trouser? This is PT intersection S divided by the probability of S. So T intersection S or S is intersection T we have already computed. This is 0.12. The probability of S is 0.2. So 0.2 here. So it will give you 0.6. This is your probability. So both the probability has been computed now. So whenever you are writing it, this is how you are going to write it or solve it. In a school, there are 1000 students, out of which 430 are girls. If it is known that out of 430, 10% of the girls study in class 12th, what is the probability that a student chosen randomly studies in class 12? So random can be, it can be a girl, it can be a boy. So what is the probability that the student chosen randomly studies in class 12 given that the chosen student is a girl? So before we go ahead, let's diagrammatically understand what is the scenario in front of us. In a school, there are 1000 in all students. In this 1000 students, there are boys and girls. 430 girls are being told are present or exist in the list. 570 are the boys. We don't have to worry about the boys because the question is all about the girl probability. Now the second thing which is being told is out of these 430 girls in all, 10% of the girls study in class 12. So from 1st to 12th class, there are in all total 430 girls, and 10% of these 430, they are studying in class 12. So 430 into 10 by 100, that is, I'm taking the 10%, that comes out to be 43. So 43 girls are present in class 12 or enrolled in class 12. So what is the probability that a student chosen randomly studies in class 12 given that the chosen student is a girl? So there will be two events that we are going to make. One event will be that it is known that chosen student is a girl. So student is a girl is one event, and student chosen randomly studies in class 12 is the second set we are going to make. So let's start with S, student chosen randomly. Again, I'm saying it can be a girl, it can be a boy. So student chosen randomly studying in class 12. So first, it is known that it is a girl. So we are making G now. So G can be student is a girl. This G is student is a girl. So S by G. This is a conditional probability. So that's how S by G will be computed. Alright. So we'll just solve this question by our basic probability definition. This PS by G is PS intersection G divided by PG. Now what is PG? Probability of a girl. Now in all there are 430 girls and there are total 1000 students. So 430 by 1000 is the PG. So choosing a girl randomly from 430 girls. So this only girl will come up is 430 by 1000. Now what is this PS intersection G? Now a girl chosen and also the girl belongs to class 12. What is that probability? That is S intersection G we are finding out. That is in all there are 1000 students. But what is our favorable cases? Total number of cases is 1000. What is our favorable cases? 10% girls are in 12th class. So this will be 43 by 1000. So PS intersection G is 43 by 1000, which is the girl, and girl also in class 12 is 43 by 1000, and then choosing a girl from all the 1000s, which is the PG, that having a girl from 1000 possibilities. So in all it will be 430 divided by 1000. So when you divide them, it will be 1 by 10. The required probability is 1 by 10. Now how this will be done? This is how you are going to go about it. Right? It's a tricky question, but you will understand it. 10 cards numbered 1 to 10 are placed in box, mixed up thoroughly, and then one card is drawn randomly. So let's make the sample space. Sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cards in all, mixed up thoroughly, then one card is drawn randomly. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? So it is from 4 to 10. If it is known that the number on the card is more than 3, it is already known that the number on the card is from 4 to 10. What is the probability that it is an even number? So we'll make two different event. A is even numbers on the card. It can be 2, 4, 6, 8, 10. So A said let's make it like this. So it will be, we are talking about even numbers on the card. So 1 to 10, 2, 4, 6, 8, 10 are the even numbers on the card. Number of elements in A is how many? 5. Now B said we are making number which appears is more than 3. So more than 3 on the card means it has to be from 4 to 10. So the set becomes like this. 3 is not inclusive. More than 3 means you have to start with 4. 4, 5, 6, 7, 8, 9 and 10. So number of elements in B is how many? These are in all 7. Now we have to find out the intersection here. A intersection B. How many values are common in both the sets or found in both the sets? It will be 4, 6, 8 and 10. So number of elements in A intersection B is 4. Now probability of A by B. That is how we made these events and sets. That is, we are aware that the number on the card is more than 3, which is set B. What is the probability that it is an even number, which is set A? A by B is PA intersection B divided by PB. Let's make it N because we are dealing with numbers. This will be 4, A intersection B is 4 and 7 is the denominator and B, which is 4 by 7 is the answer. So this is a very straightforward question. I hope you'll be able to do it by yourself only because this question has been taken in the previous discussion also. Assume that each child born is equally likely to be a boy or a girl. So again, this question is also being done, similar question, but those who have not understood or want some recall. So equally likely means 50% chances of girl or boy being born is possible. If the family has 2 children, so 2 children are there, what is the conditional probability that both are girls given that? So this is given, conditional probability. The youngest is a girl, at least one is a girl. So let's make the sample space. See, 2 kids means both can be boys. First boy, second boy. Then we have both the girls, G1, G2. 1 boy, 1 girl, or 1 girl, 1 boy. So this is in all the total sample space. Sample space, let's write it in a formal way. Same thing I'm writing formally here. It will be B1, B2, B1, G2, G1, B2 and G1, G2. Same thing we have done here. Now let's make A here. We'll make this as B and C because you know that the thing which are known goes in the below. So B, we are making the youngest is a girl. So I'm just writing in short. You already know it is given. The question is noticeable also here. So the youngest is a girl is B and at least one is a girl. At least one is a girl because we want A by B and A by C. That's why I have taken B and C as these two. Now what is the conditional probability that both are girls? So A we are interested in which are both the girls. Both are girls. That's why we made it as set A. Now let's make A. We are making the set both are girls. So G1, G2. Then B. B is youngest is a girl. Means the second child should be a girl. So G2, G2 should be there. So where all we have G2, G2. So G1, G2 and B1, G2 is a possibility. So I'm taking it actually from the sample space only. So B1, G2 and G1, G2. C is what? C is at least one is a girl. At least one is a girl. So the only total boy is can be ignored. Others can be taken. So B1, G2, G1, B2 and G1, G2. So all these three have at least one girl. Number of elements in A is what? 1. Number of elements in B is 2. Number of elements in C is 3. Now P A by B we will find out and P A by C. That is both are girls. If it is given that youngest is a girl is P A by B and both are girls if at least one is a girl is P A by C. It will be P A intersection B by PB, P A by B and P A by C is P intersection C by PC. Now A intersection B let's find out first. A intersection B, what is the common values? Only G1, G2 which we find is the common value. So let's write it as G1, G2. So number of elements in A intersection B is only 1, G1, G2. So let's write it as 1. Now A intersection C. A and C when you intersect, again G1, G2 because A has only G1, G2. So G1, G2 again. So this is again 1. Number of elements in A intersection C is 1 only. Now put it here in the question. P intersection B is 1. P intersection C is 1. What is PB which is number of elements in B? So I'm just making it as N. Number of elements in B. We have already computed that. It's 2. Number of elements in C, which is 3. So 1 by 3. 1 by 2 and 1 by 3 are the respective probabilities. Now whatever we have discussed is given here. You can follow this. Okay. So this is all about this discussion. Thank you so much and have a good one.